If you followed along with this channel, you know that for the last 2 years, the only part of my house using solar has been this hybrid mini split. And I love this thing. During the day, this mini split helps cool the living room without pulling any power from the grid. But the mini split can only use the power it needs at that moment. If the panels are capable of producing more, there's nowhere for that extra energy to go. It can't be saved for later. And once the sun goes down, the mini split has to go back to using power from the house. So to fix that problem, you buy a battery, which is what I did, so that it could power the critical loads panel on my house, which consists of all 3 mini splits, the refrigerator, the septic pump, the kitchen lights, and some of the living room outlets like where the TV and internet are plugged into. The goal is to use more of the solar energy I'm producing, store some of it for later, and keep these things running when the grid goes down. Now, what I ended up purchasing was the EG4 12000 XP inverter, which cost me $1,899, and one EG4 314 amp hour battery, which cost $3,399. And then I already had 7 450 watt bifacial solar panels that originally came with the hybrid mini split. Now, during the day, the panels power the critical loads and send whatever is left into the battery. If the house needs more power than the panels are producing, the battery starts to supply the difference. I have the inverter set to use the battery until it reaches 30%. At that point, the critical load panel automatically switches back to the grid. And the grid runs the loads, but I don't have it recharge the battery. I leave that for the solar panels. Once solar brings the battery back to 40%, the critical load panel switches back to the inverter. Now, EG4 recommends using at least 2 batteries with the 12000 XP, and the reason comes down to how much power the batteries can provide at one time. The inverter is capable of delivering 12,000 watts, but one battery can't supply the full 12,000 watts by itself. This battery, for example, has a maximum discharge limit of 200 amps. At around 51 volts, that works out to roughly 10,000 watts. However, the recommended continuous discharge rate for the battery longevity is 157 amps, which works out to around 8,000 watts. With 2 batteries, the load is divided between them. That allows the inverter to use more of its full 12,000 watt capacity without demanding as much from each battery. But my critical loads don't need anywhere close to 12,000 watts. Even with all 3 mini splits running, along with the refrigerator and everything else on the panel, the highest load I've seen is around 3,500 to 4,000 watts. Now, to be fair, I haven't caught the exact moment when the septic pump starts, but it's only a 1/3 horsepower pump, so I don't expect it to push the total anywhere close to what this battery can provide. And during the day, the solar panels help supply some of that power too. So 2 batteries would allow me to use more of the inverter's capacity, but for the way I'm using this system, 1 battery should, in theory, be able to handle the load. So, can it? Starting July 15th, the system was up and running, and I collected data through August 6th, so that gave me 23 full days to see how it performed. Now, during that time, I wasn't shutting things off to make the battery last longer. I wasn't turning on extra loads to make the test harder. We just used the house like we normally do. This is also during summer, so several afternoons were in the mid to upper 90s, and we had days over 100 degrees. So here are the numbers from July 15th to August 6th. The 7 panels have a combined rating of 3,150 watts, but the highest output I recorded during this test was 2,870 watts, which I did not expect to get the full 3,150 watt rating because that is based on ideal test conditions. Actual output changes with the heat, the angle of the sun, normal losses throughout the system. But even without reaching their full rating, the panels still produced an average of about 18.8 kilowatt hours each day. Now, the critical loads panel used about 21.7 kilowatt hours a day. Of that, about 15.8 kilowatt hours were supplied by the inverter using solar and energy stored in the battery. The remaining 5.9 kilowatt hours came from the grid. During the strongest part of the day, the panels were producing enough power to run the critical loads and charge the battery at the same time. So why was I still pulling almost 6 kilowatt hours from the grid each day? Well, the reason becomes clearer when you look at what the battery was doing. The battery was often reaching 30% overnight or early in the morning. That put the critical load panel back on the grid until solar could bring the battery up to 40% again. During these 23 days, the battery's state of charge reached about 67% on an average. The best day reached 83%, and the lowest, it only reached 46%. So when solar production started falling in the evening, the house started using more power than the panels were producing. At that point, the battery stopped charging and started covering the difference. So I never had a full battery by the time the sun set. July 30th is a good example of what a normal day looked like. The battery started the day at 29%. So when I woke up, the house was already using grid power. Solar came in that morning and started charging the battery. Just after 9 a.m., it reached 40%, and the house was able to leave the grid. From there, the panels and battery carried everything. The panels were running the critical loads and sending whatever was left into the battery. The battery reached 67% that afternoon. Then, around 3:20 p.m., the house started using more power than the panels were producing, and the battery began covering the difference. Now, solar stopped producing around 7:40 p.m. From that point on, the battery was carrying the full load. It reached 30% and returned to the grid at about 10:45 p.m. that night. Now, altogether, the house operated without grid power for about 13 hours and 41 minutes. And that was with the battery only reaching a max 67% state of charge. So, can one 16 kilowatt hour battery run the important parts of my house? Yes. So far, it's handled everything extremely well. All 3 mini splits can run at the same time. The refrigerator, septic pump, lights, TV, internet can all run with them. The problem isn't whether the battery can provide enough power to run those things. The problem is how long it can keep running them after solar production drops. Right now, with my current amount of solar, I'm not getting the battery close to a full charge. That means I'm starting the evening with less stored energy than I could have. And being able to make it through the night is important to us for more than just lowering the electric bill. While I was working on this video, a wildfire started near us. The fire reached areas around our community and some people had to evacuate. Now, thankfully, we didn't lose power. But seeing something like this nearby is a reminder that an outage might not always just last a few hours. A wildfire or another natural disaster could damage power lines and leave us without electricity much longer. Now, I don't expect this system to make us completely independent from the grid, but I would like to know that if something happens, we can keep things going. To get to that point, what I need next is more solar and another battery. But taking this step by step, which I've been doing, my next step will be adding more panels. The part I haven't figured out yet is where I want to put them permanently. I need to choose a location and then build something to hold them. That could take me a while as I'm currently pretty busy. But I can still use the panels while I figure that out. For now, I can set them out on the concrete patio I have and connect them directly to the hybrid mini split. That would allow those panels to power the living room air conditioner during the day. It would also take one of the largest daytime loads off the main system. That leaves more of the existing solar available to run the rest of the house and charge the battery. Once I figure out where I want to put the new panels permanently, I can then move them over to the 12,000 XP. After that, I'll add another battery. But for now, I'm going to keep running the house with just one and see how it performs for the rest of the summer.